All right, everybody. Welcome to the video for lesson 4 on comparing different quadratic functions. Um, so for the video, I'm going to kind of take you through the lesson, and then in class tomorrow, we'll go through and go over the homework together. So the first thing is the opening exercise. It asks us to use the graph of this quadratic function in the table, and it says to determine the vertex of the function, and how can we recognize the vertex from the graph, and how do we recognize it from the table. So here, I want you to take a couple minutes and try and make a table from the graph, identify the vertex in both, and then kind of describe how you can figure it out from both of them. So go ahead and pause the video and try this problem. All right, so I'm hoping that you paused the video and tried this. So looking at the graph, I'm looking for nice points. So those are the 5 points I identified. We see our nice symmetrical graph here. So from the table, the vertex or the turning point where the graph changes direction is here. From the table, that same point is located here. Notice the y values are decreasing towards -1 from both directions. So for that problem right below where it says, like, what is the vertex of the function, right? We know it's -2, -1, right? From the graph, it's the minimum, sometimes the maximum. From the table, it's the point where the y values change direction. Okay, what's the y-intercept? Well, that's 0, 3. From the graph, it's where it crosses the y-axis. From table, it's the point with x value of 0. What are the x-intercepts? So those would be -3, 0 and -1, 0. From the graph, it's where it crosses x-axis. From table, it's points with 0 for the y value. If you could identify those 3 different things from the table and from the graph, you're going to be good for this lesson when you start comparing these functions. So let's take a look at a couple functions. So it says, which of the following quadratic functions has the largest maximum value? Whenever you hear the words maximum or minimum, they're talking about vertex. And it asks us to justify our answer. So I'm going to do the 2 easy ones first, and then we'll talk about the harder one, or the different one here for a second. So I'm going to look at the table first. So looking at the table, if I look at my y values, they're increasing in this direction and this direction, and they continue increasing until you get to this point of 1, 9. So this vertex has the point 1, 9. If I look at the graph, I have 1, 2, 3, 4, and 5. So it looks like this vertex is around 1, 2 and a half, 4 and a half. I don't know for sure, but that's what it looks like. So we'll just take a kind of educated guess there what that one is. So far, n of x has the largest y value or the largest maximum value. Let's talk about f of x for a second. So for f of x, I got to graph this in my calculator. So I could do that either in Desmos or I could do that on my graphing calculator to see what the maximum value is. I'm going to use Desmos because that's what I have access to right now. So let me get here to Desmos. And it's negative 1/4 x squared. Oh my. Why can't I get my normal screen up here? Hold on 1 second, guys. Sorry, I'm not used to Desmos here, guys. Can't find the caret button. All right, so for this one, the vertex at 4, 7, right? I couldn't find the caret button, so if I just did x times x, but you could have the caret button on your calculator, I'm sure. So this one has a vertex of 4, 7, making n of x has the largest vertex, aka maximum. All right. For the next one, I asked which one has the smallest y-intercept. All right, so for the graph one, the y-intercept is here. So that's 1, 2, 3, 4, 5, 6, 7, 8. This one has a y-intercept of 0, -8. To find the y-intercept for the other two, you just have to plug in 0 for x. So for this one, we would have 2 times 0 squared plus 5 times 0 minus 4. So the y-intercept would be at 0, -4 if you evaluate that. If you plug in 0 for this next function, you're going to get 0 plus 2, 0 minus 5. So you're going to get the y-intercept of 0, -10. If you evaluate that, you get -10, right? So g of x has the smallest y-intercept. All right, the next one goes over average rate of change again. This is something we did in the first lesson. It was a review of something we did in a previous unit. So whenever we hear average rate of change, here's what we have to think, right? We have to think that the average rate of change is equal to the function value of the second value minus the function value of the first value, and then the second value minus the first value. So if I find the average rate of change from 1 to 4 for f of x, so the average rate of change from 1 to 4 is going to be these 2 points that we care about here and here. So the function value at the x value of 4 is 9. The function value at the x value of 1 is 12. So the average rate of change is going to be -3 over 3 or -1. For h of x, I need to figure out, well, what is h of 1 and what is h of 4? So if I plug in 1, I'm going to get -1 minus 1 plus 6 or 4. And if I plug in 4, I'm going to get -16 minus 4 plus 6, which is -14. So the average rate of change is going to be -14 minus 4 divided by 4 minus 1. Or if we simplify that, -18 over 3, which is -6. So far, h of x has the largest average rate of change over that interval. From the x value of 1 to the x value of 4, I have the points 1, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. -9, 2, 4, 0. So the average rate of change here for k of x is going to be 0 minus -9 over 4 minus 1. So the average rate of change here is going to be 9 over 3, which is just 3. So which one has the largest average rate of change is going to be k of x. Because 3 is the largest number out of those 3 answers we just got. For number 4, it says, using the 3 quadratic functions above, determine which function's vertex has the largest x value. Justify your reasoning. So the largest x value of the vertex. So let's take a look. So we had 3 functions here. So f of x has a vertex of, looking at that table, right? If we look at the y values, they're converging to 13. So there's your vertex. Here, my vertex we already found, that's the minimum, 1, -9. So we have 2, 13 for f. where k of x has a vertex of 1, -9. For the equation, we got to graph that one. So let's go back to Desmos. Let's have that adventure here again. So we have negative x squared. I'm just going to leave my x times x in there. And minus x plus 6. So we'll go minus x minus 6. And we can see the vertex there is negative 0.5, negative 5.75. Oh, no, it's plus 6. Let's fix that. Plus 6. So we have a vertex here of negative 0.5, positive 6.25. So h of x has a vertex of negative 0.5, positive 6.25. So which of these has the largest x value would be f of x. Because that x value is the largest. All right, looking at just these x values here, here, and here, 2 is the biggest number. And that's it. All right, hopefully this video helped with the lesson. If you have any questions about it, let me know tomorrow when we go over the homework assignment. See you all soon.